On my workbench today is a Panasonic SA-700. Looks to be a fairly high quality stereo receiver. When I type Panasonic SA-700 into the internet, all I get is a Technics SA-700, which is a much more modern, well, not like modern in today's standards, but I would say 5 to 10 years younger of a stereo system by Technics, had the same model name. But this one, my brother received from, I think it was a Vietnam vet, or Korean War vet. I don't remember. No, it would have been probably, yeah, it would have been Vietnam. Yeah, for sure. And he actually bought this right from a store in Japan while he was there. So while he was overseas. So very interesting. My brother says that one of the channels is out. So I'm just going to see if it even powers up right now. I've got my dim bulb tester up on the wall there. I can let you see what that's all about, which is right there. So there's 3 bulbs, that is a 60 watt, I'm sorry, a 40 watt, a 60 watt, and a 100 watt at the top. So I can vary the amount of current that I want to go put into the stereo receiver. And so at the very bottom of the dim bulb tester, which is right there, is where I have the stereo receiver plugged into this dedicated outlet just for the dim bulb tester, and a meter that tells me the voltage and the wattage, amperage, whatever, everything I need to know. So I'm going to keep it at the 40 watt bulb for now, just to see if there's any problems here. So let's turn it on. Yeah, lights come on very dimly, as you can see that. I'm sorry about the reflection there, but yeah, you can see that there is a glow from the channels and from probably a strength meter on the left side. So I do have lights coming on, but I will open it up in a bit. He says, yeah, one channel is missing or out. It probably needs to be recapped, which I'll probably do, and it definitely needs a cleaning. This thing is really, it's very filthy, so I'll have to deal with that too. And here's the back of the receiver, which has, it's pretty interesting. It's pretty complex, so it shows the quality of this particular receiver. FM sensitivity switch, DX or local, kind of a crude FM antenna that somebody put on there, and AM antenna connection, phono 1, phono 2, so 2 different turntables you can put on there, recording and playback, a unusual jack, which I don't know what that's called for recording and play, a remote speakers connections here, which have jumpers in them. Don't know really what's that's all about. Main speakers, 8 ohm output, and also voltage change from 110, 125, 210, 220, 240 switch there, which is pretty neat. A player source, which is a 3-prong jack of some sort, and then a switched 150 watt max outlet, so pretty nice. So here I've got the receiver upside down. To remove the guts of the receiver, there were 5 screws, 1, 2, 3, 4, 5, not part of the feet screws, which is nice. So you can keep the feet on there, you just have to take off the 5 that are surrounding it. Just a word of warning, you can see here, they have an FM antenna. I didn't see it until I started to pull the guts out. There's an FM antenna that they actually have it stapled to the bottom of the top of the chassis. So it's literally stapled to the wood on the inside. It only goes around maybe about 2/3 of the way around, but it's an FM antenna that you have to unscrew from the back of the unit before you slide the unit out toward the front. This is the back of the unit here, obviously. So just a word of warning, so you don't go having to do any more soldering. So on the front panel, you got bass, treble, balance, and volume. I keep the volume down low for this particular test I'm about to do. I've got the unit on right now. You can barely see the lighted panel, and then I flip the camera upside down here. There's an incandescent bulb that does work there and there, but there's one over here that's burnt out, so that's why it's kind of dim on the front. This thing definitely needs a major cleaning. I'm going to just take an air gun to it. It's mostly dust that I'm dealing with right now that I can see. The air gun will definitely clean it up very nicely. But so here's my 8 ohm output speaker leads here. I'm going to do just a DC test to those real quick, make sure there's no DC going out. And here's another view of the receiver, back of the SA-700 Panasonic. Looks fairly easy to work on, which everything's very nice and open. I certainly appreciate that. One thing I definitely want to do though, because to do my tests, I typically just send a signal into the RCA jacks, and if you look, they are heavily corroded. Pretty much all of these connections are heavily corroded, so I'm going to have to spend some time cleaning those before I do anything else. Well, these contacts are so corroded that I tried just using a cotton swab with some alcohol, and then I tried using contact cleaner, you know, going around them. It's so corroded, so pitted, that I'm using 240 rated grit paper. It's emery cloth would be better, but I don't have any emery cloth with, you know, the fabric back. This just has a paper back, so you got to take your time and just kind of go around very gently, and you'll get there. But yeah, it's really pretty pitted pretty badly. And once I'm done, once I'm happy with the results that I see on every terminal, then I'll go back and I will use just basic rubbing alcohol. I'll put that on a cotton swab and go around just to clean it up and clean the back of this panel. I'll probably use rubbing alcohol or some cleaner just to get all this off, some non-water cleaner, or low water cleaner I should say. And then when I'm finally done, I usually put on Ideal's Nolox, which is an antioxidant. I put that a thin layer of that around and into the middle of the terminals. Now I've seen guys on the internet, they unwrap a lot of the cotton off of the, oh, by the way, don't buy the cheap cotton swabs, buy Q-tip brand cotton swabs. The cheaper ones, they bend and break, they're just a pain to deal with. Quality Q-tips are the best. Buy the Q-tip name brand. They are by far the best. And then anyway, to get the inside of that cleaned out, you remove a lot of the cotton here, and the cotton actually acts as a slightly abrasive, and as an abrasive. So I'll put some Nolex, I'll put rubbing alcohol on there first just to clean it out, then I'll put a little bit of Nolex on there and just run it in and out of the inside of these RCA terminals. But in the end, it's by putting an antioxidant on it, these should last a long time without having to be re-cleaned. Okay, so I've got all the RCA jacks nice and cleaned up, and I basically just shined a light through from the inside out. You can kind of see it. I don't know if you can see it on the camera there, but all the inside terminals were nice and shiny clean. So it was just moisture that collected, just kind of came out of the air and collected on the outside. And now they're all nice and shiny, good contact. So I took the air gun to it, so the circuit board is much cleaner than it was, so I can see the components better. And now I'm going to take the front faceplate off because it's really grimy, and that way I can do some spray cleaning of these slide potentiometers. Alright, well, here's the cover taken off. A lot of static was keeping the dust on here, but there was a brown residue on the whole top here, brown residue along the sides, brown residue on this whole area. So now it's all clean and shiny. I just used isopropyl rubbing alcohol, and that came off just fine and didn't affect the print at all, which is nice. I should have really done a test patch, but it's all good. Just trying to deal with the static electricity though. The static is just sucking all the flakes of dust from the. I was just using toilet paper to clean this whole thing, and I also used a contact cleaner. I jetted that into each of these slide potentiometers, and I also jetted it into the little hole that's at the front of the switches. There's no way to get it in the back, so all the more reason it's nice to take this cover off. Jet contact cleaner in there, and then exercise them. Same with these, exercise them, and then spray them again, exercise them, make sure that any residue that gets in there gets out. So now everything's clean and dried off, all good to go. There's also 4 fuses here, 1, 2, 3, 4. I noticed that there's corrosion on these fuse holders, so I'm going to take those fuses out and clean those also. These fuses, boy, I hate it when manufacturers do this. These fuses that are a pain in the butt to replace. They should just put a fuse holder in them, but they're too cheap to do that, obviously. So those, obviously, there's no corrosion. They're just soldered in place, so I don't have to worry about those. I did test continuity with all 4 of those. They're all good. But yeah, I definitely want to clean those contacts and the fuses themselves, clean all the corrosion off. Okay, so now that I've got everything cleaned up, I've got the unit turned on and I've got it under my dim bulb tester at 40 watts on the 40 watt bulb again. So I can't expect, there could be some issues with this at 40 watts, but I'd rather be safe than sorry just for the moment. And as I mentioned on the previous video, I did check for voltage here on DC from plus and minus. On the left channel, I've got 0.008, which probably doesn't mean squat. And over here, I think I have I have 0.032 microvolts. So that's pretty good. I mean, that's about standard, I'm sure. The plus and minus of your DC coming in, let's see, let's check that right now. From the caps, these big filter caps, 19.3 volts there, and that is the plus voltage, 19.3. Over here would be your minus. You can see basically what's nice too is these caps are clearly marked plus and minus. So you get your minus 19.2 volts. Very nice.
And so it was a fun adventure.
Well, can you hear that? That's the FM station. I found out not only it wasn't just one channel that was out, both channels were out. So let me hit the volume down on that. So what I did do, sorry I did it off camera, but I just don't have time to keep going back and forth. What I did do off camera was I took the audio input that I was taking off of my cell phone over here. I took that out and I simply used right here, a non-polar capacitor, and I simply connected that up via one of these riggings, male to female, back to the male that was on the back there, and so that I could send a signal through, if I can get it loose here, through this non-polar capacitor. And then what I did do, jeepers creepers, sorry about that. So then what I did was I checked the volume, by the way. I made sure the volume was turned down very low on my cell phone because I didn't want to send any large signals through here. I want a very low signal through here because I wasn't exactly sure where I was poking and prodding, so I didn't want to blast, audio through to my tiny speakers that I have mounted up high here for my test speakers. So anyway, what I did do is okay, so from the front of the board here, here's your bass, your treble, your balance, and your volume. Okay, so there's your volume. And what I did do is I simply, okay, so here's the back of that same board right there. And see these wires here? No, not this blue wire, but these 3 wires here, that's your right and left channel and your ground that come from the, you can hear it humming, that comes from your control board up here that goes through to the amplifier board right there. So what I did do was I basically backtracked from right and left channel, backtrack, and just found spots on the board where I could actually hear audio coming through the amplifier section. And so I had to make sure that not only did I keep the volume low on my cell phone, but I had to keep the volume low here, because there again, I didn't want to blast audio through the amplifier just in case I was hitting a soft spot, as it were, on the circuit board. So I backtracked, all the way back to the volume control. And you can see, I'm like, why in the world? This is when I had the cover still on the thing, because I had put the cover on when you saw the last video, and now I had to take it off again because I saw these solder joints, and I'm like, well, why in the world are there all these solder joints just for those controls? When I had it off earlier, I did not look closely at the front here. If you look closely at the front here, there's all that circuitry. You see the circuitry in between? So here's your base, and there's circuitry, treble circuitry, balance circuitry, volume circuitry. So in this cavity here is 2 transistors and some capacitors and such. The capacitors, these smaller capacitors, rarely ever go bad. So I just assumed that maybe the transistors were bad. So I tested the transistors, which are basically on the back side here. I tested them as NPNs or PNPs, I don't even remember. Either way, they tested okay via just a voltmeter in the diode mode of my voltmeter. And then down here, I see a big capacitor, which I moved to right there. See that capacitor? It's a 220 microfarad 16 volt capacitor. That capacitor was, whoops, sorry about that, bumped the volume. That capacitor was on the front right down here. I thought, well, what the heck? Let me take that capacitor off and test it, because larger capacitors are more apt to go bad than a smaller capacitor. I take it off, and I'll show you right here. Let me put you up on my tripod here for a moment. Okay, don't know if you can read this. I'll angle it up toward the camera. But let me turn it on here. It's a Atlas ESR cap meter. Turn it on. Here's the capacitor that was on the unit. Connect it up here. It says it's monitoring right now. In circuit leaky. So that capacitor was bad. And guess what? So I go ahead and I put that new capacitor, as I said, I put it right in here because it was just easier for me to solder it back into place. So I put it right there. And now both channels work just perfectly. So that's the only thing wrong with this entire amplifier as far as I can tell. I mean, it sounds great. It sounds absolutely beautiful. So, and the balance is working, right left channel, the treble's working. It's not a huge amount of difference in the treble or the bass, but they are working. I can definitely hear a difference between lighter bass and lower bass. This is not good music for really testing that, but nonetheless, take my word for it. So, all this just for one capacitor. Oh well. Hey, I'm happy though. And I do need to replace that one bulb that's out on the dial here. Okay, well, I put in new LED lighting into the front panel here. Sorry about the glare there. But early in my earlier videos, you could see the incandescent bulbs were so ridiculously dim that you couldn't even see any of this without really struggling. So now with the LED lighting, it's a beautiful thing. You've got your FM stereo indicator. I like how this it's kind of like a neat thing that they put in there. You can see how it moves. It's just a metal plate that basically shuts off the light as you turn the dial, which is pretty cool. I think I've never seen anything quite like that. It's pretty neat. And then a power strength meter, which, sorry from the glare of this thing, you can't really see it, but it's nice and clear. If you see it in person, it's very nice and clear. And how I did that was I bought a reel of warm white LED strip lights like this, and they have a scissors mark wherever you can cut it. So every 3 whoops, sorry about that, every 3 LEDs you can cut this, and so each segment can be powered by 12 volts DC. And they even have, if you look very closely on here, you can see a plus and a minus where the tabs are on each side of this thing, plus and minus for wiring up your wires, your black and your red, positive and negative to them. So 12 volts for each of these 3 segments, and that's, I think it comes as like 5 meters of it or something. It's quite a bit. For I think it was only like $10 or something like that, or $12 maybe, but it was pretty cheap, as I recall. Been years since I bought that, but it finally came in handy for sure, because the warm white, that's warm white, you know, mimics an incandescent bulb. And so the 2 incandescent bulbs that were at the very bottom here and the incandescent bulb right here all got replaced with a LED plate. And even that bar graph indicator for where you are on the dial, that's also an LED plate that's literally shoved in perpendicular to the faceplate, and that's real nice. And then I replaced the grain of wheat bulb that was for the FM indicator with a very bright clear lens LED, green LED. Is they had RCA jacks on the back for your speaker output. I thought that was ridiculous, so I added these 2. These are your spring-loaded jacks. Show it to you there a little bit better. And I did kind of a crude installation, but hey, it works great. And then I just jumped the wires over to the RCA jack inputs, or yeah, outputs. I mean, and then what was here is this ridiculous connector, which I have no idea why Panasonic would have put this on the back for your tape in and outs. We're going through this thing if you wanted to. They do have regular RCA jacks at the bottom here for the tape in and out, right there, if you can see them. So I don't know why in the world they even bothered with this goofy thing. No, I've never seen anybody use something like that. So anyway, I replaced it with those spring-loaded jacks, which is quite nice. So one thing I wanted to add for the LED lighting that I added to this thing, the manufacturer originally had it so that the LED lights, the FM dial lights and the FM fixed signal strength light, all those incandescent lights, they actually had them turn off when you would move this dial, as far as I could tell. The reason they did that is because they knew incandescent lights don't like to stay on for long periods of time without burning out. So they thought, well, let's have them turn off whenever they switch off the FM. So that's what they did. So I have it wired now so that the LED lights stay on all the time, because what the heck, it looks nice. So what I had to do was, this is your power going out. This is an actual winding by the way, I've got the thing unplugged right now, so that's why I'm touching all this stuff. I had to add this bridge rectifier. This was the output for those lights. It was a AC wiring going out for incandescent. I had to wire in a bridge rectifier right there, as you can see it. I also had to add one diode. There's a diode in here. All of these LED lights only draw about 0.2 of an amp, which is beautiful. As bright as they are, it's beautiful. So I did have to add one diode in here because I had to do some load tests to it, a very careful load test, so I didn't burn out the LEDs. And I found out that the bridge rectifier with one diode on the DC plus output brought the voltage down to 12 volts right on the money. So it was beautiful in that respect. So it's kind of a mess of wiring here, and I'm just going to leave it like that, because that way I can easily futz with it in the future if I need to. It's not hurting anything, and it's certainly not going to be affected by any vibration or anything like that. So after all that, this receiver sounds great. It's just a beautiful thing. Whoop, it's out of tune right now because I moved the dial.
Greatest escape. Kindness is the truest form of royalty.
Join us for the timeless classic.
Certainly sounds beautiful. So thanks for watching.